Tutorial on writing formulas of binary ionic compounds. In order to understand how to write chemical formulas for ionic compounds, you have to have a good understanding of two things first. The first thing is this, what an ionic compound is, and this is just a general working definition of what an ionic compound is. It's a compound that is composed of a metal and a nonmetal that are held together by an ionic bond. You'll notice here that I have beside metal cation and beside nonmetal anion. And if you remember back to the tutorial on ions and ionic charges, a cation is just a metal ion, metal element that is formed an ion by losing its valence electrons, and it takes on a charge that's equal to the number of electrons that it's lost. And an anion is a non-metal element that becomes an ion by gaining electrons, and usually it'll gain as many electrons as it needs to have a full stable octet, 8 valence electrons, and its charge will be equal to the number of electrons that it gains. So that is going to form an ionic bond, and this ionic bond is just simply a bond that forms between the cation and the anion, the metal and the nonmetal. And it's based on the attractive forces between the two. And a good thing to remember here is that opposite charges attract. Now here are some general rules for writing formulas for ionic compounds. Please bear in mind that not all of these rules are applied all the time. Some of them are kind of subjective. So, and I'll walk you through what rules get used in what cases by going through 4 examples after this. Now, until you get really good at doing this, and some people get to the point where they can do this, they write chemical formulas in their head. If you take enough chemistry, you'll get to that point where they can kind of skip over a lot of this stuff and really just go right to writing the formula itself. They can do a lot of the not really, it's not difficult math, but they can do the math in their head and they can figure out what the formula is. But we would always start off with this, write the atomic symbol of each element, and we'd have the metal first and the nonmetal second. We'd write the charge of the ion of the element superscripted to the right of each atomic symbol. And then 3 and 4 and 5. These are situational. Now the first case here might be if the charges are not equal, then we cross over the charges and write the absolute value of each charge, subscripted to the right of each atomic symbol. And this is called the crisscross method in chemistry. We do this probably, I'm going to say 75% of the time. This is the one rule that you're going to follow. Another possibility is this: if the charges are equal but opposite, the ratio of elements is 1:1, and you don't use the crisscross method. This is a really nice case here when you get a formula that you have to write like this. It's really easy. And then number 5, simplify the formulas if possible. Now this, you're not going to have to do this that often. However, it's something that you need to understand and be able to do, because otherwise sometimes you'll get a chemical formula wrong. You'll follow this rule, crisscrossing over the charges, and you'll end up with an incorrect formula until you simplify it by dividing through by a 2 or 3 or something like that. Then you end up with the actual formula. And the last thing here, check to make sure the overall charge on the compound is 0. In regular ionic compounds, the compounds that we're going to be dealing with right now, the overall charge on the compound is always going to be 0. So that means that the negative charge is always going to be balanced out by a positive charge. Now, before we go on and we look at the examples, let's just do a really quick review of ionic charges. Now, everything in group 1A here should have a positive 1 charge. Everything in group 2A, a positive 2 charge over here, positive 3. And 3A, 4A should be plus or minus 4. 5A is going to be negative 3. 6A is going to be negative 2. 7A is going to be negative 1. And hey, these guys over here, well, they don't apply. I should just say, and I was about to write no. They don't form ions in the way that the other elements do. They can do things, but you're not going to have to worry about that in grade 10 chemistry or grade 9 chemistry for that matter either. So those are what the charges are. And again, these elements here, the metals, they lose electrons to take on a positive charge. The nonmetals from 5A over, they gain electrons to take on a negative charge. And the elements in group 4A, they have the ability to become positive or negative. Now, some of them have, let's just say, I hate to anthropomorphize this and talk about these elements like they're living, breathing things, because they're not. But some of them have a preference for whether or not they're negative or positive. And Whether or not they're negative positive is sometimes situational. For example, if carbon is combining with something like lithium, like a metal, lithium can't take on a negative charge. It has to be positive, and in order for lithium to combine with carbon, carbon has to take on a negative charge. So just an example of how those elements might work. And I think I have another, I have an actual example coming up here that deals with carbon. So the first example here is lithium, and it combines with nitrogen. So the first thing that I will do is I will write down the atomic symbol for lithium. I will write down the atomic symbol for nitrogen. I'm going to write in the charge for lithium. It's +1. The charge for nitrogen is -3. And then we use the crisscross method here. Now this wasn't in my actual rules, but this is what the crisscross method is. I'm taking the absolute value of this charge and I'm going to put it down here. And I'm going to take the absolute value of this charge and I'm going to put it down here, subscripted beside the element. So this is what the crossover, crisscross, implies that we're taking that number and just moving it down. Just the number, not the actual charge. I can't have +1 nitrogen or -3 lithium. It doesn't work like that. I can, however, have 3 lithium and 1 nitrogen. But you'll notice here that I'm not going to write in the number 1. And one of the conventions in chemistry for writing chemical formulas is for ionic compounds, we don't write in the number 1. We don't. If it's one element that's supposed to be present, then we just write in the symbol for that element and it's considered to be 1 there. Fair enough? And this then is my formula for lithium combining with nitrogen. The actual name of this compound would be lithium nitride. And to see if I'm actually correct, if this formula is correct, it has to have an overall charge of 0. Now how do I figure that out? Well, if I have, let's just see here. If I have 3 of these lithium and each one has a +1 charge, then the overall charge on the metals, the metal ions, is +3. And if I have this 1 nitrogen with a -1 charge, or -3 charge rather, its overall charge on the nonmetals in this compound is -3. And we look here, +3, -3, 0. This is the correct formula. Okay. So, moving on. The next one here we have magnesium combining with oxygen. Again, we start with writing the atomic symbol for each element, and then we write in the charges. Magnesium is located in group 2A. It has a +2 charge, as it loses 2 valence electrons. Oxygen is located in group 6A, and it's going to gain 2 electrons to have 8. So it'll have a -2 charge. Now this is a case where this rule applies. If the charges are equal but opposite, the ratio of elements is 1:1. Do not use the crisscross method. Now what exactly does that mean? Well, it just means this. These 2 charges cancel each other out. +2, -2, that equals 0. So the actual formula in this case here is just MgO, a 1:1 ratio of the one element to the other one. Now, example number 3, calcium combines with arsenic. Calcium is located in group 2A. It has a +2 charge. It's going to lose 2 electrons. And arsenic here is located in group 5A. Oops, I wrote that down wrong. I was about to put AR, and it's not AR. It's AS. And it is located in 5A, and it has a -3 charge. The charges here are not opposite, or not equal. So we're going to use the crisscross method. That means we're going to have 3 calcium for every 2 arsenic. And again, we can check this by doing that little check that I had before. If each calcium has a +2 charge and we have 3 of them, that's going to work out to +6. And if we've got 2 arsenic, each one with a -3 charge, that'll work out to -6. Our overall charge is 0. So this is the correct formula. Now, you're probably wondering, do I have to do this all the time? No, you don't. What is really important is that you just, or at least what's really important to me, is that you have the correct formula. And if you consistently can get the correct formula, you don't have to worry about doing all these little extra steps. And the last one here, we have magnesium combining with carbon. So let's start by writing our atomic symbols. Magnesium is located in group 2A, has a +2 charge. And it's combining with carbon. Carbon's located in group 4A, and again, that's one of those special cases where the charge can be either -4 or +4. Because it's combining with a metal, it's going to take on the -4 charge. And we're going to use the crisscross method here, and we're going to get Mg4C 2. Now, this is a case where that second last rule applies. Simplify the formulas if possible. And if you look at this, we can simplify this. If we divide through by 2, we end up with this, Mg2C. And if we check that formula to see if it's correct, we're going to find that if we have 2 magnesium, each with a positive 2 charge, the overall charge on the cations, the metals, is positive 4. And if we have 1 carbon with a negative 4 charge, the overall charge there is negative 4. So this is the actual correct formula for the compound that contains magnesium and carbon, called magnesium carbide, or one form of it anyways. So this is a case where we have to simplify. If we don't, what this actually is, it's like writing 2 times this. Okay, really. So there we go. There's 4 examples for you on how to write chemical formulas for ionic compounds. Should you have any questions, please do not hesitate to contact me with them.